Physical and chemical properties of chlorine. Physical properties. It is a greenish yellow gas with an unpleasant choking smell. 2. It is moderately soluble in water. 3. It is about 2.5 times denser than air. 4. It is a poisonous gas. Chemical properties of chlorine. Direct combination. It combines directly with sodium, zinc, and iron to give their respective chlorides. 2. It reacts with ammonia to give nitrogen and hydrogen chloride gas. 3. It reacts with sodium hydroxide in cold and concentrated form, given sodium isochlorate 1 and sodium triisochlorate 5 in their respective cases. This reaction is very important and must be noted because most questions try to test the strength of the student based on this reaction. And in this reaction, we are talking about sodium hydroxide in cold and in concentrated form, giving sodium oxochlorate 1 and sodium triisochlorate 1. So in this situation now, when chlorine reacts with sodium hydroxide, then the reaction of chlorine with sodium hydroxide in concentrated form, then in cold, that is the dilute form. So this situation is 1 to 2 ratio in the dilute form. Take note of that, 1 to 2 ratio, 1 to 2. Then in the concentrated form is 3 to 6 ratio. Take note of that because they test this aspect of chemistry or this aspect of chemical property of chlorine in most exams. So in this situation, you have isochlorate 1 plus water. Then here we have, it says aqueous, liquid. Then in this situation we have this plus water. So now balance this reaction. We have, how many chlorine do we have here? We have 6 here. So how many? So we have 6. So automatically this one is now okay. We have, this is not balanced yet. So there's another reactant here, that's sodium chloride. Sodium chloride now is balanced. Then here you have 5 moles of sodium chloride. So is it balanced? Let's check for the first one. 2 chlorine, 1, 2. Sodium 2, 1, 2. Then oxygen 2, 1, 2. Hydrogen 2, 2. So this one is balanced. Then in the other case, 6 chlorine, 1 plus 5, 6. 6 sodium, 1 plus 5, 6. Oxygen 6, 3 plus 3, 6. And hydrogen 6, 6. So it's balanced now. It's balanced now. So what it means is that when chlorine reacts with cold of sodium hydroxide, you have isochlorate 1, sodium isochlorate 1 formed and the respective products. While in the case of this, you have sodium triisochlorate 5 and the respective water and sodium chloride. So this is an important reaction, an important reaction in the chemical properties of chlorine. Then it reacts with slaked lime to produce bleaching powder. It reacts with slaked lime to produce bleaching powder. So it reacts with slaked lime to produce bleaching powder. To produce bleaching powder. So this is a bleaching powder. That's its reaction with chlorine. It reacts with slake lime. Chlorine reacts with slake lime to produce bleaching powder, and that's one of the reactions. The use of chlorine. It is a powerful germicide because of its oxidizing nature. 2. It is used as a bleaching agent for cotton. 3. It is used to manufacture several important compounds such as tetrachloromethane, trichloromethane, etc. Fluorine, which is the most reactive of the halogen. This is the most reactive element of this group, and it is prepared by electrolysis. Remember that fluorine and chlorine, they are gases, while bromine is liquid and iodine is solid. Properties of fluorine: you have it is a poisonous gas. 2. It is a yellow gas with irritating smell. 3. It combines with non-metals to give their respective fluoride. Use of fluorine: it acts as a raw material for separating isotopes of uranium. 2. It is used for fluoridation of drinking water. 3. It is used in cleaning steel. 4. It is used as refrigerant. Bromine, iodine, and other salts. Bromine is obtained from salt water, while iodine is obtained from sea water. Properties of bromine and iodine: they are all non-metals. 2. They exist as diatomic molecules. 3. They form constant boiling mixtures with distilled water. Uses of bromine and iodine. Bromine is used in the manufacture of 1,2-dibromoethane, a petrol additive. 2. Bromine is used to make dye stuff. 3. Iodine is used in making dyes for color photography. Questions. When chlorine is exposed to the atmosphere, the product form are hydrochloric acid and oxygen. B. Chlorine gas and oxochlorate 1 acid. C. Oxygen and oxochlorate 1 acid. D. Hydrogen and oxygen. 2. The bleaching action of chlorine in water is because of A. Its reducing property. B. Its oxidizing property. C. It is a strong acid. D. It is a weak acid. 3. The reaction between common salt and concentrated tetraoxosulfate 6 liberates A. Sulfur 4 oxide. B. Hydrogen chloride gas. C. Hydrogen sulfide gas. D. Hydrogen gas. Now, answer to question number 1. When chlorine is exposed to the atmosphere, the product form. When chlorine is exposed to the atmosphere. When you expose chlorine to the atmosphere, as oxygen will interfere with it, in that situation, you have the production of this compound as oxochlorate 1 acid. So in this regard, then what we have at the end, when this is now exposed to sunlight, you have hydrochloric acid plus oxygen that will be produced in the process. So in this situation, when chlorine is exposed to the atmosphere, the product form are hydrochloric acid and oxygen. That is the answer. So A is hydrochloric acid and oxygen. Number 2, the bleaching action of chlorine in water is because chlorine is never a reducing agent. It is oxidizing agent because of the fact that it is an electron acceptor. Therefore, B is the answer because of its oxidizing property. C, the reaction between common salt and and concentrated tetraoxosulfate 6 acid liberates when common salt is sodium chloride reacting with concentrated tetraoxosulfate 6 acid. So in this situation, we have an acidic salt formed, sodium, hydrogen, tetrasulfate 6 acid, and what will be left is hydrogen chloride. So you have this formed. Sodium hydrogen, then hydrogen chloride. So in that situation, so the answer to the question will be A is sulfur 4 oxide, B is hydrogen chloride gas, C is hydrogen sulfide, and D is hydrogen gas. So automatically the answer will definitely be hydrogen chloride gas, because when this reacts with the concentrated form, you have the production of hydrochloric, you have the formation of acidic salts of this metal and sodium hydrogen tetrasulfate 6, then hydrogen chloride gas. So the answer there is B, hydrogen chloride gas.